Hello, I'm Jarek Pociuk. I'm a principal software engineer at Polydia and a PMC member of Apache Airflow, and I would like to talk to you about Breeze today. Okay, why Breeze? My team started to work on Airflow in 2018, and when we started, we thought it's fairly difficult to start developing for Airflow. Setting up development environment was rather hard, and we thought it should be a breeze to contribute to Airflow. That was our tagline. So, what is Breeze? Breeze is a development and test environment. It's written in Bash, so it can be run anywhere, and it focuses on reducing overhead for development. Mainly, it is all about speed of iteration, avoiding repeatable tasks, and it supports all kinds of testing that you can imagine for Airflow. It integrates well with CI tests, so you can run the same tests locally and in CI environment. And it is also helpful in preparing releases and images. Okay, so first I will tell you about how to install Breeze. Okay, so first some prerequisites. Breeze doesn't have a lot of prerequisites. It merely requires you to have Docker and Docker Compose installed because it uses Docker for all the execution. And as you can see, I have an empty Docker installation. I have no images whatsoever. I just have a plain Docker installation, and Docker Compose is installed in the right version. So first thing that you should do when you want to install Breeze is to clone the Apache Airflow repository. So Breeze is part of the source code of Apache Airflow, and it's best to use it from master, and that's where we are doing development. So if you see, there is a Breeze script when you check out the Airflow repository, and there is also a Breeze complete, which allows to set up auto-completion. So everything that you run is like run Breeze is like just run Breeze command. And first thing that you should do is like you should set up the autocomplete, because that will help you to see what kind of options you can see. So Breeze setup autocomplete, it will just set it up for you. You can see both for Bash and for ZSH. And once you install it, you have to just run this one script. And once you have it, you have all the parameters of Breeze autocompletable, like in the usual scripts that you can have, or usual tools that you can have. And you can also run help, as you see. The help will tell you more about each of the command. It can tell you about the command themselves, about what you can do with those commands. The first thing that you do is like you really want to do is like run Breeze simply like that. And what it will do, it will simply install and download and prepare all the images and that are needed to run Breeze command. It is all happening automatically. You don't have to worry about that. This is all happening. I mean, this recording is in real time. I've got quite fast network. It might be a little bit slower for you because it has to download like a gigabyte of Docker images. But this is all happening automatically, and also Breeze makes sure that all those images are kept updated while you are developing. And the next step that Breeze does, it downloads the images and then it rebuilds the images so that to make sure that whatever you have is actually the latest version. Then it will build all the web compilation of JavaScript and drops you in the shell, and that's about it. Let's talk about running tests on Breeze. Okay, Breeze is very useful for to run tests. So in order to run tests, you just enter Breeze. You see this nice ASCII art that we have, but also some useful information about the test environment that you're using, including the branch version that you're from, the Docker image that you're from, the version of Airflow that you're from, the Python version that is used. You can also see the database that is used, because we can choose different database. More about this later. And you can see some useful cheat sheet information, so like how you can make it even easier to use Breeze, and information about port forwarding, because you can directly access the databases and web server from your host environment. So how to do testing in Breeze? It's actually super easy, because everything is prepared when you enter Breeze. You just run PyTest, and then you choose the test that you want to run, and autocomplete works nicely, so you can choose the test file that you want to run, and when you run it, well, as expected, it will just run. It will do all the things that are needed for you to run, so it creates a database. If it's missing, it will run the tests and provide the results of these tests. So this is the simplest way how you can just start running tests immediately using the command line. This is all done in Docker, so it's a bit more difficult to run it from your IDE, but you can run it as a command line for your tests, and it's actually super useful, and you see all the tests passed in this case. Yeah. So once you finished, you can exit, and you're back in your host environment. Now I will show you how to select backend in Python, and how to make sure to make the best use of Breeze. Breeze has a built-in help, so we can see all the different commands. I'll tell more about those later. And for every command, you can also type in that -- help and see the detailed information, what each command does, with some examples. And you also can see different flags that Breeze has. Like it has tons of flags. And not all of them you will be using, but the first ones are those really useful ones. So first of all, you can choose the Python version that you want to run on, and then secondly, you can choose the backend version, so database that you want to use for the backend. So it can be SQLite, MySQL, or Postgres. You can even choose the version of Postgres or version of MySQL that you want to use. And autocomplete helps you to choose the right version, so you can see you can type Breeze Python, and then you can choose the right options that you can have. So you can autocomplete the command and autocomplete the values for that command, which is actually pretty useful when you don't remember all the options that you have. So now you can choose both Python and backend version. So in this case, we are using Python 3.8 and backend MySQL database. And first thing that Breeze does, it checks if it needs to run and download and build the image for you for this particular Python version. And in this case, I didn't have any Python version installed, or Python 3.8 installed. So it will download and rebuild the image locally, because Breeze has built-in mechanism to choose the fastest way for you to get the images. If you already downloaded a recent version of image, it will just rebuild it locally because it's much faster. But if you have an old version, or you didn't install the particular Python version image with Breeze, then it will download it from the server, from our registry, and rebuild it, which is much faster than rebuilding it from the scratch, because rebuilding from the scratch takes 15-20 minutes, depends on the speed of network you have and the computer you have. So this will be this is what Breeze does. It will just downloads all the necessary images for you on demand when you need it, and then rebuilds it locally automatically, so that the latest version of your sources is used. And as you can see here, we chose MySQL as backend, and I didn't have MySQL image as well, so Breeze will automatically download it for you and will start it. And while entering Breeze, it will check if the backend is running, and it will wait until it is running. And once you enter Breeze as a shell, via the shell, you can see that the database is running, and all the tests that you will be executing, they will be run using the MySQL database in this case. the environment variables are set properly for it. And when you do, for example, Airflow DB reset, the reset will be happening in the MySQL database that is running as a Docker image. And now, when you run tests, you can run all the kinds of tests in Breeze. I'll tell a little bit more about the integration tests and other kind of tests in the future, in the near future, in the further part of the video. In this case, I just chose like one simple test, but you can run all the different kinds of like core tests. And when you run it with MySQL in Breeze, the MySQL database will be used during all those tests. And this also reflects what we are doing on CI, because in our CI system we also run all the tests against Postgres, MySQL, and SQLite, and you can very easily this way reproduce it here and rerun. If the test fails only for MySQL, you can run a MySQL environment. You can also choose other environment, Postgres. Yeah, it's as easy as just choosing different backend. And again, Breeze will simply download the Docker image for you, start the Postgres database, and it will wait until it is started and ready. And in this case, again, DB reset will run the reset and recreate the Airflow database in Postgres this time. You can run tests again, and those tests will this time run using the Postgres backend. So this is like super easy way, without you having to configure your own Postgres, your own MySQL, and set all the configuration parameters, etc. Like Breeze does it all automatically for you. You don't have to worry about you just have to run tests. This is like your job as a developer, not to set up the whole environment. It's just run tests when the environment is set up for you automatically. So the nice thing about Breeze is that it runs all those backend databases if you exit Breeze as well, so they are not killed. So the data that is stored there is still there, and Breeze also remembers the last choice that you made on Python backend and other options. And when you enter, it will, as you see, again you used Postgres as a backend. So you don't even have to remember to pass all the options. Breeze will just use whatever you used for the last time. You can actually do a lot more things with Airflow. As you see, Airflow has different commands, and one of the nice commands that we have is db shell. And db shell will drop you into the specific shell for the database you use, so you don't even have to know how to drop in. Like Airflow db shell will drop you to the right database, and then you can run like select query and see the results of it. And you can also use the forwarded port connections that I mentioned before, so you can connect to the database directly if you have any kind of client for the database, or your IDE can talk directly to the database. This is all automatically forwarded for you. Then you just don't forget to run Breeze stop when you finish working with Breeze, because that will actually kill and stop the databases, and that's one thing. If you want to recreate the database from the scratch, you can use that. Now a few words about using multiple terminals. We enter the Docker container in a shell, and often we would like to start several processes in the interactive way and observe the output of it. And for that, we have Tmux installed inside the Docker container. Tmux is a terminal multiplexer, and it allows you, when you enter it, it allows you to multiply your terminal. So you can just press Ctrl B and like quote or %, depend how you want to split the screen. These are kind of basic shortcuts, and you can switch between those terminals with your Ctrl B arrow, up, down, left, right. And these are just the basic shortcuts. There are more that you can follow. And in each terminal, you can run your commands separately, and you will be able to see the output of those commands and interact with those commands. So, for example, in one of those commands, first we want to, one of those terminals, we want to reset the database. Okay, that's easy. The database is reset. Now we want to start the scheduler. So we start the Airflow scheduler in this terminal. And now if we had one terminal, we would be blocked because we cannot do more. We can put it in the background, but it's not very convenient. So we have another terminal, we switch to it, and now we can run Airflow web server in this terminal. And we can interact with both outputs from terminal and from scheduler. We can see what's going on, and we can switch to another terminal and then try to interact with the rest of the system. So for example, we can just enter the shell, the DB shell, and interact with the database, for example, or observe the logs, or do whatever you want. And run any other commands. And you can switch, you can mix and match, you can open new terminal, you can zoom in the terminal, zoom out, back, all these via custom commands of Tmux. It's a very useful tool. It requires a little bit of getting used to, but generally is something I recommend to use. So now the same thing with exec. We can use Docker exec to enter into a running container, and this is a standard Docker command, and Breeze has the support for that. So like when you run Breeze exec command, it will find running Docker container and join it. So right now I run Docker Breeze Docker container, and I create a database in it. And I'm just creating a new user because I want to show you the whole Airflow running in a moment. So I create the admin user, and then in the second terminal I just type breeze exec, and that command will find the right container and will join it, and that command will allow you to run a separate terminal and multiple of them. So this is just two shell commands, two shells. Shell processes in the same container. So in the first shell process, in the first terminal, I'm running the Airflow scheduler. In the other, I'm running Airflow web server. And as you will see shortly, the port of the web server is forwarded from host. As you maybe recall, when you start Breeze, the links are printed there, so you can just click there on the link and use admin in this case because that's the user I created, and see the running web server UI of Airflow. Right, so I'd like to tell a little bit about the cloud tools that we support. Often when you use Airflow, you want to interact with some external services like gCloud, AWS, Azure, and for all those standard cloud providers, there are some tools, standard CLI tools that you use to interact with them, like gCloud here. They are quite substantial, quite big, because they have lots of functionality. So it would be kind of wasteful to bake them into the image. The Docker image is already pretty large that we're using. So we've done a quite clever way of linking them with some scripts, so that when you run gCloud command, what will happen is that the gCloud binary or gCloud Docker image will be downloaded in the background, and the gCloud command will run from that Docker image. So very similarly with AWS, and very similarly with Azure client. And this is again the same philosophy, like to make it as fast as possible to run your system and iterate on it, and then only download something when you actually need and use it. So if you don't use Azure client, you will not have to download it. It will be downloaded on demand the first time that you are using it. That's actually pretty cool. And what's even cooler is that those images stay downloaded. So if you exit the bash and the breeze and re-enter it again, those tools are there. You don't have to lose time on downloading them. They are just used from the Docker image, which is already downloaded, and you can use it simply like that. So now integrations. What you could see before in the movie was running simple tests, but some of the tests run in Airflow require some extra integration. As you can see here, you can run Airflow with integration flag, and you can choose different integrations, and all of this is auto-completable. So you can choose Cassandra, Mongo, Redis, and a few others. In this case, what I'm showing here is just where I'm starting 2 integrations, and this means that again, very similarly as in the previous chapter, the Redis and Mongo images are downloaded automatically, and once you start it, Breeze verifies if the integrations are ready, and then you will be able to run integration tests with those services. So PyTest, we have PyTest plugin to add certain commands, Airflow specific commands to PyTest, and one of them is integrations, and this integrations flag is used to run particular integrations with or when you are running tests. So otherwise those tests will be automatically skipped because the integration is not there. So as I want to show here, so we want to run, it will not succeed this time, but I'll show you how it works when you want to run a Redis specific test. So we have this test celery command, for example, and it has few tests which are Redis. But as you can see here, it doesn't have all the integration markers. It has it misses another integration. Some of them are not Redis, but this Redis one requires also a RabbitMQ integration. So the test requires Rabbit integration and started. So it's not only Rabbit and Mongo, but Redis and Mongo, but you also need RabbitMQ. So what you do, you can exit and you add the integration there. So you add the RabbitMQ integration because apparently this test requires both Redis and RabbitMQ. And in this case, again, those 2 were already downloaded, so they are not re-downloaded, but RabbitMQ is downloaded and started. And when we start this celery command, you will see that those tests are not skipped now, they are executed and they are passing because they are using the integrations that we started. So this is also pretty cool because those are the tests that started. This is pretty cool because then you don't have to set up your own Mongo, Redis, RabbitMQ, wherever. This is all set up automatically in the way that it's easy to run the tests. And whenever any kind of the test like that fails on CI, it's super easy to reproduce it because as you see, those Rabbit, Mongo, Redis, they are just started for you. And don't forget to stop after you use those integrations because they take precious memory and CPU when they are running. Now, one of my favorite topics, image building. I've been involved in that from the very beginning when I joined Airflow. So you can use Breeze to build the images, and there are 2 types of images: the CI images and production images. Now I'm going to show you the CI images. So those are used for the testing. Those are the images that are used to enter the containers that I showed before. So while they are built automatically, you can also build them manually using Breeze build image command, and it has a number of switches. I will not go into details. You can read all details on what they do. I will show a few examples of and few ways that you can use this build image command. But most of all, you can choose the Python version that you want to use it for, that you want to build the image from. So this is the most important switch, the Python version. So now building image is simple. It's just type Breeze build image and specify Python version if you want. Otherwise, it will just use the last version used. And once it's done, and if you already done that before, it will be pretty quick, like in this case, because it will just see that nothing changed, and it will rebuild it very quickly, or even not rebuild it at all. As the same when you choose a different version, you can see that it is quick because I already built it before. But you can also choose some flags or use some flags like in this case like force pull images. This will actually, before building, it will pull the image from the repository, from our registry, common registry, and it will build it after pulling it first, which might be faster if you have an old version of image. So sometimes you need to use it. Now, production image is much more interesting because this is production image that you will be building yourself most likely. Breeze is helpful to build it. The production image is built with the same command and with production image flag. And when you build it, it will take some time because building production image is always taken from scratch, and it is cached locally. Then when you build it, it actually builds two images. The one image is like the build image containing a compiler and containing all the dependencies which are needed to build the libraries. And the final image that we are actually publishing is much smaller. It's just image containing already built dependencies or already built binaries and Python code. So this makes it much smaller than the build image itself. So you have this image built, and you can add some extra comments, extra flags, which customize this image for you. So it will add additional development dependencies or additional dependencies in the production image, or additional Python dependencies or extras when installing Airflow. So you can specify all those different flags to build your own custom image and name it whatever you want afterwards, and distribute it for your own use in Helm chart or wherever you want to use it. But the really powerful feature of building images is that you can use it to build images from released Airflow versions. So instead of just building it like that, you add install Airflow version command, and then you can install or build the image with embedded version of Airflow taken from PyPy. And that's cool, because you can, if you want to prepare your own image using already released or even released candidate version, you can use this command to build it and take the PyPy released Airflow and embed it into the image. And once you do that, when you do that, you can also, as similarly as shown before, you can actually specify the different commands like additional extra or additional dependencies to build the image. But it's even more, because once the image is there, you can use shell command similarly as in CI images to enter the image. So like here, production image is done in the way that by default it runs Airflow, so you see Airflow commands. But you can also add bash as a command, and then you will enter there, and you will be able to see, for example, Airflow version there, and interact with the image and test it and see how it works before you release it. Okay, Breeze can also be used to run static checks. In Airflow, we have plenty of static checks, and if you do Breeze static checks --help, you will see the list of all the static checks we have, which is nicer than pre-commit, because pre-commit doesn't give you the list of all the checks and doesn't give you the autocomplete. Breeze gives you all that, so you can run Breeze static checks and tap and autocomplete the names of the checks. So if you don't remember the name, and nobody remembers because we have so many, so you can just run static check the same way as you run pre-commit. In this case, it is all skipped because pre-commit by default only runs on staging files, but you can specify any option to the pre-commit run, which is run underneath, but you have to separate it with double dash. So double dash and then double dash all files will run pre-commit check that you specify on the all files of Airflow. So this is pretty useful, and pre-commit works fairly, or autocomplete works fairly nicely, supplementing the missing pre-commit feature, and you can run it for different checks. Okay, building docs. Building docs is not as straightforward in Airflow. You need to have specific environment. So that's why we have built the docs command in Breeze to help help with this. You don't have to set up the environment. You don't have to set up virtual environment specifically for your builds. And it runs for quite some time. We sped it up now significantly just to show the end result. But what you get as an end result is that files are generated in your host in docs underscore build HTML folder. That makes it so much easy because you build it. It's actually built in the container, but you can see it immediately in your host. Okay, now some words about generating requirements. Generating requirements is needed in Airflow because we have very specific setup. I will tell about that in a moment while we are generating them. So you generate requirements only when you change setup py, and you can generate it for different Python versions. So you have to specify breeze generate requirements -- Python and Python version. Why this at all needed? This is needed because Airflow is both a library and application. So as a library, you normally want to have as open dependencies or requirements as possible so that new version of software are used by the library. But as a application, you want to have them pinned to a specific version so that you know that you can install the application and it will work, no matter if somebody released a breaking change. So Airflow is unfortunately a bit of both. So it's an application on one side because you want to run it, and on the other hand, you want to write DAGs in Python. Then it makes it like it use the Python environment as a library. So that makes it quite complex. So that's why we figured out the process to generate new requirements every time the setup py changes. And those are not a real requirements. So as you see here, you can see that some of the packages upgraded. This is just constraint files. They will let you install Airflow in consistent way, and you have to do it every time you run setup py to upgrade to latest requirements that are available. Okay, some words about virtualenv, local virtualenv. So Breeze provides you the environment to run everything in a Docker. But it's not always convenient because sometimes you want to run it in your IDE locally and have the virtual environment locally. For example, in this case, I'm just creating a virtual environment with pyenv. And I have the environment, I can enter it, and I would like to make it use Airflow, so be usable in Airflow. So usually that's a fairly simple process for most of the packages. You just install the package and that's it. However, for Airflow, it's a little bit more involved. As you see here, Airflow is not installed. For Airflow is a little bit more involved because in order to run it locally, you have to do a few more things. You have to have certain prerequisites. Yeah, you cannot just run pip install like this. Or you can, but it usually won't work. So you run breeze initialize local virtualenv, and what it does, it actually does install all the requirements in the right version. This is important because sometimes that's why it is generate requirements before. Sometimes those generate requirements will be broken, the current version, so the pip install will not simply work. You have to have a much more complex command, and Breeze does it for you and uses the latest working set of requirements. But it also tells you if you're missing prerequisites on Mac or Linux. It will tell you how to install those missing prerequisites, like some database libraries, etc., etc. Something that you have to install with apt or with brew in Mac, and it will also clean up and reset the local Airflow home. So if you know, like, Airflow has some local files it stores in home/Airflow directory if you don't specify Airflow home, and this is what Breeze Initialize environment does. It will simply create and reset the databases there. As you see now, Airflow can be imported and it works. You saw that the scheduler works out of the box, And if you look at those files generated in the Airflow in the home/Airflow, yeah, I'm just going to listing this directory. You will see that there is a default configuration there. There is a reset, empty SQLite database to be used. Logs and DAGs, logs can be written there, and there is unit test configuration, so it's usable. Now the most complex part of Airflow Breeze is like integration with Kubernetes tests. We are using Kind, which is Kubernetes in Docker, and Breeze wraps around the commands that are needed to run cluster, deploy Airflow on top of it, and run tests. So you can see there is a command kind cluster, and it has sub commands. I will explain all those sub commands one by one. The first thing that you want to do is like just to have the cluster up and running. So if you run Breeze kind cluster start, it will download all the tools that are needed to run the cluster and run Airflow on top of it, which is kind, kubectl, and Helm, and it will create and run the cluster for you. And this is the beautiful part of Kind, Kubernetes in Docker, that it actually creates a Kubernetes cluster inside of your Docker engine and run your Kubernetes cluster as a Kubernetes, as a Docker, as Docker containers. And it does it in a nice way. As you see, it displays the progress along the way. And all the complexity of setting up Kubernetes cluster and configuring it for you to run, this is all hidden, and Kind takes care about that, and we're using Kind for that. This is pretty cool development tool, and you don't have to set up your own cluster. It will be there for you to use for all the testing purposes for Airflow, and you can use it for other purposes, but in this case we are using this Breeze kind cluster command to manage it. So this is just managed by the command, and it can be run for different versions. So like you can have Python 3.6, Python 3.7, 3.8, etc. Version of the cluster. So it doesn't matter for the cluster, but it does matter which version of Airflow will be deployed on that cluster. You can also specify different versions of any of the tools that you have here, like Helm chart, kubectl, or Kind. You can specify them as command line switches. And now you have the Kubernetes cluster up and running, but it has no Airflow at all. It's just the bare cluster, which has no pods, not even in the Airflow namespace where we keep our Airflow running. That's where Helm by default installed Airflow. So the next thing that we want to do is to deploy Airflow on top of Kubernetes cluster, and it consists of several steps. And all this is hidden by a single under this single deploy command, which will do what is needed. So it will build the production image from the current sources of Airflow, and it will deploy it, install it as a Helm chart, and run the port forwarding to connect to this Airflow running in this Kubernetes cluster. So it'll be now sped up because it takes quite a bit of time to build the image for the first time, but any next time you run it, it will be much faster because it will only rebuild what has changed, and you can use it to iterate your tests with Kubernetes. So now what happens is that Breeze loads the production images which are built into the Kubernetes, the kind cluster. The kind cluster requires images to be loaded if they are built locally, and that's what happens here. It takes a little to load them, and the next thing which happens is Breeze is installing Airflow using Helm chart, using the production image that we just built, using the Helm chart, and configures it in the way that it will be usable for testing. And this is what's happening now. Again, we are not doing anything special here, but we're just providing an umbrella for all the commands that are necessary to deploy the Airflow to the cluster. And this is fairly cool because we have testing all together, like Airflow, production image, and Helm chart. They are all tested together. Now we have a web server which is forwarded to the to the web server, which is running web server port, which is forwarded to the web server running in the cluster. And as you can see, the kind cluster is running, so you can run kind cluster status to see the status of the cluster. But also we have the pods of Airflow running in the Airflow namespace. It's like Postgres database, scheduler, web server, and statsd, and they're all running, and it's basically a running Kubernetes deployment of Apache Airflow, which is cool because like before it was like fairly complex to have it. Now it's just 2 commands, and the next step which happens is like you can automatically run all the Kubernetes tests on this cluster. So you deployed your new code into the cluster using the Helm chart, and now you can run Kubernetes tests on this running Kubernetes instance, and that's super cool because you can test if the deployment works, if everything works in the cluster, and we are going to add many more tests in there. So what happens next? Breeze automatically creates the right virtual environment to run the test on, and the next step will be to actually run those tests, all of them that we have for Kubernetes. So this is something exactly the same as is done on the CI that we run. So if something fails on CI, it will fail also here most likely, and you can easily reproduce it here. And it runs all the tests that we have now. There are not many of those yet. They are sufficient for now, but we are working on many more tests, many more Kubernetes related tests, Kubernetes deployment related tests, and they all can be run with this one command. As you see, it takes a little bit of time because it communicates with the cluster, it restarts the scheduler, and does few things with running Airflow. The other tests will pass rather much quicker, yeah, so as you see, all this is super easy. You just have 3 commands of kind class of Breeze, and everything you can test using different Python versions, different Kubernetes versions, and that's pretty cool comparing to what we had before. So right now we can just do it so easily, and that enables us to write more tests because now everyone can test it more easily. If it fails, reproduce it and rerun the tests. But we are going to have many more of those tests. Those tests take like maybe a minute to run, but of course you wouldn't want to rerun all those tests every time you make a single change. So this is just a command that you run all the tests. But as Breeze is focused on increasing development speed and let's say increasing the speed of iteration with the code, so we also have a command that can help you with just running one single test easily. So you have the environment, the same kind cluster start, kind cluster deploy, but then we also have a command which is kind cluster shell. I will show it in a moment. So you run the kind cluster shell, yeah, the test succeeded. And now you can run the kind cluster shell command. And this command will drop you in this special virtual environment prepared. It will check if everything is ready for testing. And you can take any of the tests that you saw before that were run by the test command and run it in isolation, just one of them, and it will take much less time, and you can iterate and improve the tests, add more tests, and run them one by one, without redeploying Airflow. Unless you want to fix something in Airflow, then you add something to Airflow, redeploy it using Breeze kind deploy. It will be much faster than the first time because it will just incrementally add what is there. And it will redeploy Airflow, and again you can iterate much quicker with that. And of course you have to remember to stop a cluster because it takes precious resources. And speaking about resources, with memory and CPU, remember to check if your Docker containers are running, and Breeze Stop is there to help you to kill all the Docker containers that are left. Right, That was it. That was all. You can find all the information at airflowapache.org. And I hope you will become a contributor soon. Unless you are already a contributor, then I hope it will make you more efficient in contributing to Airflow. Thank you very much.